Hey everyone, welcome to our channel Engineering Debunk. Today we are going to discuss with you a very important topic which was asked in BARC interview exam. That was why this whole world are using sinusoidal wave AC electricity only. Why not any other form of AC like triangular wave AC, square wave AC? We have also trapezoidal wave AC. So today we are not only going to discuss this topic, but we will going to fill this topic by simulation software which named as LT Spice. So take pause for 2 minutes and think what could be the answer of this particular question. So I know that majority of you are thinking that two answer of this particular question. First is generation of sinusoids is very easy. And second answer is you can represent any repetitive signal in form of sine and cosine. But both answers are wrong because as electrical engineer, we all know that how difficult it is to achieve perfect sinusoidal wave, right? We need many filters for this like active filter, passive filter and many more. So that first answer is completely wrong. Now for second answer, yes, you can represent any repetitive signal in form of sine and cosine. But my question is why sine and cosine only? So this is also not correct answer for my question. Now answer is addition, subtraction, differentiation and integration of sinusoids are sinusoids only. No other waveform has this kind of uniqueness. I will explain to you what is advantage of this kind of quality which sinusoids have. But before that, I will going to show you a simulation in LT Spice software so you can easily understand this particular concept. Now we are going to show you simulation waveforms. If you are adding these two square waveform, then addition of these two waveform will give you square waveform as you can see in the simulation. But it's not supposed to be square waveform, right? Because I was told you that only sinusoids having this kind of quality. This is simulation result. So it will never going to be wrong, right? I think I might be wrong. Let's try to provide some shift to this red waveform and then trying to add this square waveform. Now see, it's not square waveform. Yes, I was right. Now let's try to subtract this two square waveform and see output doesn't change its nature. It's still in the square waveform. But now try to provide some shift in this waveform and see output doesn't remain in square waveform. It's some distorted waveform, right? So now we are going to differentiate square waveform and see output seems as a impulse waveform because we know that differentiation of square is impulse. Similarly, if you are integrate square waveform, then also it's change its nature because integration of square is going to be ramp wave. Now let's try to see this waveform. It's a trapezoidal waveform, right? If you are differentiate it, then you won't getting the trapezoidal wave. It seems like a square wave available at rising and falling edge of a waveform. And if you try to integrate it, then output is distorted ramp wave. Now let's see for sinusoids. If we are adding these two sinusoids, then addition will give you sinusoids, correct? But remember, we have to check what will be going to happen with shifted sine wave. Now we are going to provide some shift in this sine wave and see output is sinusoidal. Same way, try to subtract this two sinusoidal and see output doesn't change its behavior. Let's try to provide some shift in this waveform, but see, it's again sinusoidal. Now see, what happens if we are differentiate sinusoidal? Oh, still it's remain in sinusoidal form. Now try to integrate sine wave, but see, it's again sinusoidal. So from above simulation, all properties are verified only for sinusoidal. So now from the above simulation and observation, you are getting clear idea that addition, subtraction, differentiation and integration of sinusoids are sinusoids. Yes, it is possible that magnitude and phase will be going to change, but nature remains always same. Now you might having questioned that why I am giving so much importance toward these properties of sinusoids, right? Reason behind this is our system is made from three major component RLC. So now we will talk about resistor, right? If you are taking resistor, then V equals to IR, current having same nature as a voltage. But when it comes to inductor, that time voltage waveform is differentiation of current waveform, or you can say that current waveform is integration of voltage waveform. Similarly, for capacitor, current waveform is differentiation of voltage waveform. See, basically in power system, first component is transformer. So if you are not providing sinusoidal input to transformer, it causes very dangerous problem to the transformer. Like, let's assume that we are providing square wave AC to the transformer. So the generated output having only spikes, because we know that differentiation of square is impulse. So because of that reason, very less back EMF going to be generated. So it causes very high current flow from the primary, and it will damage the transformer. Now you are clear that why we are giving more importance toward the properties of sinusoids, right? But I know you have still some doubt that when addition and subtraction came into the picture, right? Answer is simple, KVL and KCL. For that, take this RLC series circuit, and if you have to find resultant voltage, then you have to do phasor addition of individual voltage, like voltage across resistor, voltage across capacitor and voltage across inductor. So let's assume that we are taking supply voltage as triangular wave AC. Because of behavior of inductor and capacitor, the triangular wave going to be distorted. Total output will be distorted from the input. So due to this reason, we are mainly using sinusoids in AC circuit. Here is small note that this is not sine wave. It's multiple connection of parabola with positive and negative halves, because of we are integrating ramp wave. So finally, conclusion is sinusoids are only function whose addition, subtraction, differentiation and integration are sinusoids only. Yes, it is acceptable that magnitude and phase will be going to change, but nature always remains same. That's the reason why sinusoids are called eigenfunction. Thank you.